All right. So let's see this question now. Check if array is sorted and rotated, right? So we are given an integer array of n distinct integers, and we need to check if this array is sorted and rotated in the counterclockwise direction, right? And also it is given that the input array may be sorted in either the increasing order or decreasing order, and then it is rotated, right? Also, a sorted array is not considered as sorted and rotated. That is, there should be at least one rotation, right? So if you just have a plain sorted array, for example, 1, 2, 3, 4, then this won't be considered as sorted and rotated. It should have at least one rotation. It should not have zero rotations, right? So that is the problem statement entirely. Now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay. So now if you see this particular input, this example, if you see this particular array, right? Now, obviously this particular array is sorted and rotated, and that's why our output is true. The original array would have been 1, 2, 3, 4. And then if I rotate that 1, 2, 3, 4 in the counterclockwise direction 2 times, I would end up getting 3, 4, 1, 2, right? But now, an important property of a sorted and rotated array, if you think logically, would be that whatever is the original sorting order of the array, whatever is the sorting order of the original array, if I rotate that original sorted array, uh, no matter how many number of times, there will be exactly one point where, the original sorting order will be violated, right? And that will be the pivot point, right? So that will be the point from where my rotation actually starts, right? So at that particular point, the original sorting order of the array would be violated, right? So if I somehow get to know what is the original sorting order of this particular array, and then I just need to check if that particular sorting order of the original array is violated exactly once or not in this entire array, right? If it is violated exactly once, then I can comfortably declare this particular array as sorted and rotated, right? If it is not at all violated in the entire array, like if the if the original sorting order is intact in the entire array for all the elements, then also it is not sorted and rotated. And if it is violated more than once also, then also we can't call it as sorted and rotated, right? It will be sorted and rotated only if this particular original sorting order of the array would be violated exactly once, right? And that would obviously be at the point of the pivot from where the rotation begins. But that is like immaterial over here. We are not supposed to find the index over here. I mean, of course, we can find the index also. That will be also pretty easy. But right now, all what we need to do is we need to scan the entire array and then figure out if the original sorting order has been violated exactly once or not, right? And to identify what is the original sorting order of this particular array, there is a simple trick that we can follow. So for example, if you see this particular array, now the original array would have been 1, 2, 3, 4, right? And after it was rotated twice, we got this, right? But in the original array, if you see, this last element of this current array would have been before the first element of the current array, right? And so if I just compare the last element with the first element, and for example over here, if you see, the last element is lesser than the first element of the current array, right? That means when this element was over here, in fact, this order would have been increasing, right? Because after 2, I'm getting a bigger element, right? So that would mean that this particular array is actually sorted in increasing order, right? And the original sorting order of this particular array is increasing, right? So that's why we can just compare the last element of the current array with the first element of the current array, and whatever the order we get would be the original sorting order of this particular array. And that's what we need to check in the entire array, if that is exactly once violated or not, right? If it is exactly once violated in the entire array, that means this particular array is sorted and rotated. And if it is not violated exactly once, if it is maybe 0 or more than once, the violations, then it is not sorted and rotated, right? So that's the simple algorithm. And to code this, that would be pretty simple. We just need to first compare the last element with the first element and define the sorting order. And after that, we just need to check for that particular sorting order violation in this entire array and just keep a track of the count, right? The moment we get more than one violation, we can just return false. And if we don't get like more than one violation and we get exactly one violation, we can return true, right? So that's the entire approach that we can follow to solve this particular question. Now maybe let's jump to the IDE and code the solution along. All right, so let's just implement the solution now that we just discussed. So what I'll do is I'll just declare a function, maybe check rotated and sorted like this. And this will accept an integer array and the size of the array itself, right? And now what I need to do is I need to identify the original sorting order of the array, and how I will do it is by comparing the last element with the first element, right? So maybe I will just declare a boolean type variable is increasing, and this will be true if my first element is greater than the last element of the current array, right? In that case, this is increasing will be true, and my sorting order, that would mean my sorting order is increasing, right? And now to check whether it is sorted and rotated or not, the given array, I will have to see if there is exactly one violation in the current array of this original sorting order or not. And that will be tracked using the count variable, which will be initialized to 0. But whenever I find any violation, it will be incremented. And if I find more than one violation, obviously using this count variable, I will be able to say that it is not sorted and rotated, right? So let's just implement that. So what I will do is I will run a loop over the array. I will say for I in range n minus 1. So I will go one character before the last character of the array. Why? Because at every position, this is what I'm going to do. At every iteration, this is the if condition that I'm going to write. If my array of I is greater than array of I plus 1, that means I'm looking at the next element sitting at the current element always. That's why I will go one character before the last character to look at the last character in this particular condition, right? And this should be if this is true, and if my is increasing variable is also true, then what I should do is this would mean that my condition has been, my sorting order has been violated, and so I should increase my count variable by 1, right? Why it is violated? Because essentially I'm saying that my is increasing variable is true. That means my original sorting order is increasing, but over here I'm seeing otherwise, right? My current variable, my current character, or the current integer rather, is actually greater than the next integer, right? So that means there is a violation, and I will just increase my count variable by 1, right? This is the condition when my is increasing is true, right? But if my original sorting order was decreasing originally, then my is increasing variable would be false, right? So I will just reverse this condition, and I will also reverse this, right? Now this will be a violation in case my original sorting order was decreasing, and in that case I will also like put else if over here instead of if, right? And in that case also I will just increment my count by 1, right? And then after doing this, in every iteration itself, I will check if at any point my count of like violations that I'm tracking using CNT variable is greater than 1, I will just return false, right? And if not, then I will just come out of the for loop and I will check for once if my CNT is equal to 0. That means there has been no violation at all. In that case also I should return false, right? Like this. And if not, I will just return true. That means I have got exactly one violation, and that's why I should return true now, right? So this would be the simple code to implement this particular algorithm. I hope you understood it well. Now maybe what we can do is we can quickly test this using the sample test case that we saw while defining the problem, right? So I will just call this, just give me a minute. Let me just copy it from here, right? Like this, and then I will call it with 3, 4, 1, 2, and the size would be 4. This should return me true. Let's see what happens. Let me run again. Okay, it is running now. It's a bit slow, but yeah, I got true, right? So this is the final solution to this particular problem. I hope you understood it, and I will see you in the next video. Thank you.